Okay, today's lesson is Unit 1, Lesson 8. And so if you will notice this different heading from what we've had before, that's because I like the way it was presented in the book better than the alternative that I had. And so I want you to know that you can always go to your book to get more information. I'm trying to condense it and give you the most important information. If you want, excuse me, more examples than what I'm doing for you on this video, I hope you will go look in your book or come see me. All right. So first off, again, as I've said, inequalities, I want to make sure we know what it is because I'm always about that vocab. So what does it mean to have inequalities? What are inequalities? It's whenever we have these two symbols, okay? And one of the things that I want you to know about it, sometimes people have a hard time telling which one is the less than and which one is the greater than. So if you take the symbol, you can do this with your hands. If you open both of your palms, your hands out, palms facing away from you, your hands will make this symbol. Well, if you take both of them and you rotate, you can see that one of them makes an L. If I try to do it for this one and rotate it, it's not going to make an L. Okay, I just rotated it that much. So that's rotating your hand that way. And this one, I have my hand looking like that, and if you rotate it that way, you can see that that makes the L. Well, that means that is the less than symbol. Okay, and it's important to know because when you're translating from English to math, you have to know which one is which because we always read from left to right. So first off, x is greater than 4. We have x is greater than 4. The difference for x is greater than or equal to 4, we've talked about this already, so I'm going to go quickly, is the fact that you color in the endpoint. It's a, oopsie, it's a solid endpoint, not a hollow. X is less than 4, looks like this, and x is less than or equal to 4, looks like that. Okay, now, just as we use properties of equality to solve equations, we use properties of inequality to solve inequalities. So I am going to talk about the properties, and unlike geometry, when you use them, you don't have to justify each step and tell me the name of the property, but I want you to be familiar because you will probably see this again at some point. So let's go through. The first one that we have, if A is greater than B and B is greater than C, then I know that A is greater than C. And I hope you were all jumping at the chance to say that is the transitive property. Then we have, if A is greater than B, then A plus C is greater than B plus C. So what did we do is we added C to both sides of our inequality, and nothing changes, everything is the same. So this is the addition property of inequality. Next, A is greater than B, then A minus C is greater than B minus C. And that, of course, is subtraction. And then we have, we'll just go with this. If A is greater than B and C is greater than 0, then A times C. So this is multiplication. And I'm going to come back and talk about what else you see there. This is multiplication. And then the last one, of course, is division. Now, what I want to point out about these is you need to notice, I want a highlighter, okay? You need to notice that the multiplication and division have this little extra piece, okay? And what's so important, this says C is greater than 0, and this says C is less than 0. So what kind of numbers are greater than 0? Positive. What is less than 0 are negative. And so I'm hoping that you could see that when you multiply or divide by a negative number, you had to switch the sign. These started off as greater than, but they both switched to less than when you multiplied by a negative number. So again, here it is, a real concrete example. Multiplied both sides by -4, then my inequality changed from greater than to less than. Okay, 12 is greater than 6, but when I divide both sides by a negative number, then I have to flip it. And that's so important that I want to write it again down here. when solving inequalities, remember to, woohoo, I'm still in the highlighter. Let's go back to the pen. Let's go here. I'm here. Okay. So remember to flip the inequality when you multiply or divide by a negative number. Now, the other kind of inequality that we're going to work with today is something when two inequalities are joined by the word and or, then we call that a compound inequality. So just again, so you know what it is, what it means, but this word and I'll talk about it when we get to those examples, are very important and must always be an answer if they're part of the problem. Okay, so the examples I do, you have lots of examples in your book, and so I like to do more examples. So if you want more than what I'm doing, you can go back into the book and see some that are similar to what I have done here. And generally my examples will include the even problems from your homework. So if you are on our calendar and look at the end of this, you will see a list of the homework problems that we have, and you will notice that I will be doing one problem from each set of directions. So if you get stuck and don't really know what to do, you can go back to the examples and look at what I've done. Okay, write the inequality that represents the sentence. 6 less than a number is greater than 54. Well, notice that I have less than and greater than in that same sentence. Okay, don't think that we're going to have two inequality symbols. What is most important is the one that has the form of the verb to be. Is greater than is the one that's going to have our symbol. Okay, so greater than next to a form of the verb to be. Am, is, are, was, were. You didn't know you'd have an English lesson in the middle of your math video. But that's the one that's going to have our symbol with it. So we have 54 over here. And my students had no trouble remembering and knowing that 6 less than a number is x minus 6. So this is just a practice in translating, and we're good to go. Next, we have solve each inequality, graph the solution. Okay, so to solve something means that we're trying to get that variable all by itself. So I'm going to get rid of the 24 by dividing. Now, I'm dividing. The number that I'm dividing by is a positive number, not a negative number, so I do not need to flip it. And so it stays the same. Negative 12 over 24 is negative 1/2, and then I have x. Now, it is perfectly acceptable for you to leave your answer like that, but I am going to flip it just to remind you that if you choose to put x on this side and the number on that side, so if I flip this, I do have to remember to flip the inequality. So this would be the algebraic answer. Again, this is an acceptable answer, not a problem. Now, why would I go to the trouble to flip it? Okay, the reason I would go to the trouble to flip it is because then when I graph it, let's go back to my, okay, when I graph it, we always have to put 0 and negative 1/2. As I have mentioned several times, if the variable is on the left side of your equation, then the inequality symbol points to the way you shade. So I'm going to put a circle on here. Do I color it in? I do, because it has equals, so I'm going to color it in. And I'm going to shade to the left, because that's the way my arrow is pointing, and we always put an arrow on that so we know that it continues. And so, again, you can leave it like this. Just know that if the variable's on that side, you got to shade the opposite way that it's pointing. So, again, just a quick review. All right, 24. This is what I want. All right, so how do we want to start that? We're going to add 6 to both sides. So to get that 6 over, I add, and that's going to give me 4 times n minus 2 is greater than 24. And then my students said they want to divide by 4, which is perfectly okay because it goes in evenly. I'm good for that. So the 4 divided by 4 over here leaves me with n minus 2. 24 divided by 4 is 6. And then to bring that 2 over, we're going to add, because we do the opposite of what we see, or the inverse, excuse me. So n is greater than 8. And that is my algebraic answer. And we have to graph it. So, come on. There we go. Let's go graph. And we're going to have, over there. So I have 0, and I have 8, and I put a circle on 8. I do not color it in because there is no equals with it, and it's pointing to the right, so I'm going to shade to the right. All right, moving on to your next set. So then we have a word problem, and we talked about in class, one of the good strategies, I think, for doing a word problem, is to draw a picture, okay? Read it. I have to read it multiple times. So I've read this problem many times, but a lot of times when it comes a new problem, I read it many times to understand what they're asking me. The length of a picture frame is 3 inches greater than the width. The perimeter is less than 52 inches. Describe the dimensions of the frame. So I have a picture frame, and I'm going to say that picture frame's a rectangle, excuse me. And the length is greater than the width. So when I have something like that in a sentence, I always choose the variable for the shorter one, and then I know that I just have to add to that one to get the longer one. And it is a rectangle, so we know that opposite sides are congruent. And so there's my picture. Now it told me the perimeter is less than 52. Well, how do I find the perimeter of a rectangle? Everybody knew. I'm going to add up the sides. So that's one side, 2, 3. Those are the 4 sides. That is less than 52. So I'm going to add those up. I have 4w, and 3 plus 3 is 6. And we subtract 6. So 4w is less than 46, because 52 minus 6 is 46. And then I divide by 4, and 4 goes into 46 11 times, with 2 left over, and 2 out of 4 is half. 11.5. 11 and a half, if you want to write 11 and a half. So we have that w is less than 11.5. So to describe the dimensions, we're going to say the width is less than 11.5 inches, and the length is less than, some people have confusion about this, but remember, if the width is 11.5, then this is 11.5 plus 3. So that's going to give me 14.5 inches. And that's good enough to describe it. All right. Next 2. Is the inequality sometimes, always, sometimes, or never true? So when you look at this inequality, most of my students said, let's go ahead and divide by 9, because they saw 9 times something. And that gives me x plus 2 is greater than x minus 3. And a lot of people were able to tell me at that point, but I want to go ahead to the next step because sometimes it's not so obvious for people. Because the next step would be to collect your variables. So you collect your variables by subtracting x. Well, if you notice, since you have an x on both sides, they're going to cancel out, leaving you with the statement that 2 is greater than negative 3. And if 2 is greater than negative 3, you think to yourself, is that always true, sometimes true, or never true? And that answer is always true. A positive number is always larger than a negative number. So we're good. All right, let's look at the next one. 4x minus 8 is greater than 1 plus, well, weird. Okay, 1 plus 4 times that quantity. I'm not going to divide by 4 here because I'd have to divide this one by 4. And these are no problem, but 4 doesn't go into that. So we're just going to go ahead and distribute. And that's going to give us 4x minus 8 is greater than 1 plus 4x plus 12. I'm going to simplify the right side. 4x minus 8 is greater than 4x plus 13. Again, you want to collect your variables. So I got a 4x on both sides. That's going to go away, leaving me with negative 8 is greater than 13. Well, that was a true statement. This is a false statement. Is this always, sometimes, or never true? Well, it's false, so that means it can never be true. Now, the other thing that we talked about, some people asked, when is the answer going to be sometimes? And it took a while for people to realize, but sometimes it's going to be your answer if the variable doesn't fall out on both sides. So if you were left with something like x is greater than 3 when you solved an inequality, well, sometimes that's true. That's true if x is 4, but it's not true if x is 2. So that's an example of when it would be sometimes true. All right, so the last two things that we got to talk about, compound inequalities, okay? And as I said, the very important part of it is that word in there, whether it's and or. So you have that word. Regardless, you have two inequalities, so you solve them as normal. I'm going to divide by 2. I have an x, and I have a negative 5. Uh-oh, do I have a negative 5? That means do I need to flip it? The answer is no, because the number that I divided by is positive. Does not matter what the answer is. The 2 that I wrote for division is positive, so I do not flip it. You must write the word and in your answer. And then this, I'm going to divide both sides by 9. And I need to pause for a second. So when we divide both sides by 9, we'll end up with x is less than 2. We're not dividing by negative numbers, so no need to flip it. So that is our algebraic answer. We're supposed to solve. That's the answer when we solve it, and now we have to graph it. So you draw your number line, and then we have 0, and we have negative 5, and we have 2. Just make 2 closer to 0 than negative 5. Put a circle on each one. I do not color in each one because neither one has equals. Now, this is the thing about an and statement. I'm going to come down a little bit here. Okay? If it's an and statement, you got to remember that it must satisfy both conditions. So you're looking for those numbers that are greater than negative 5 and less than 2. So greater than negative 5 goes this way, and less than 2 goes this way. So I hope that you can see the numbers that satisfy both conditions are what we call the overlap or the intersection. So do not put this on your graph. This is not the way to graph the solution. Your solution looks like this. Okay? So generally, more times than not, an and will be a in between your values. Okay? And I'm going to say something else about that in just 1 second. Let me finish up. And so now we have 8x is greater than negative 2. I'm going to divide both sides by 8. And I'm going to have x is greater than negative 4. I do not flip it because that's not a negative number. And then I have or, because this is our key word this time. Divide both sides by negative 6. And I get x is greater than or equal to negative 48 divided by 6 is not 4, it's negative 8. So that is our answer algebraically. Now let's go, I'm going to hit the line. Graph it. Here is my number line. And so we have 0, we have negative 4, and then we have negative 8. I put a circle on each one. I do not color in negative 4 because there's no equals. I do color in that. And it tells me x is greater than negative 4. And are y'all yelling at me yet? Because I didn't even pay attention because I dropped my pen. We divided by a negative number here, y'all. So we were supposed to flip that. Okay, greater than here, divided by negative, flip that inequality. X is less than negative 8. And that means that this is what our graph looks like. Now, one of the things that I pointed out to them, okay, that you might want to be familiar with is that an or statement, sorry, an or statement, if you notice this graph from geometry, this is a ray. Ray starts with the letter R, or has the R in it. So more times than not, when you have an or statement, you will have rays. Okay? This over here, if you remember from geometry, is a line with two endpoints. And if you have a line with two endpoints, we have a segment. You can go at the end, but I'm going to talk about it some more, but it's important to remember. Or is generally going to be rays, and an and will be segment, and we will tie that in with the next couple of lessons. So I hope that helped. If you have any questions, please don't hesitate to email me or come see me. Thank you very much.